love the chase and the hunt, and I set the pace when I'm running. I always
Namaste Friends. So today is chapter 98 in the entire Python. And in the science Python, this is chapter 9. And this is a final chapter. So this final chapter will be in two parts, part 1 and part 2. The previous lecture we saw about interpolation. So today we'll be seeing about the statistical significance test. Today's lecture, there is no coding. It's all only, just pure theory. Next lecture will be coding. And after this, I'm seriously thinking I'm more or less going towards Panda, because Panda is so important. It is used in data analysis, and it is the right thing right now. Whether you go for PySpark or whatever, you can actually use Panda and SQL. So that is what I'm actually planning on. So let me see. Let me actually zoom in that. It's either this or Django. So let me actually think about it. But having coming to this today's lecture, which is a 98th one, what is the statistical significance? It's basically, as the name says, it is all about statistics. It means that the result that was produced has a reason behind it. It was not produced randomly or by a chance. Now, suppose many of us may be humble. We may say like, hey, you know what? I was lucky enough to get it. But in pure statistics, there was a reason behind it. Whether you call it karma or whether you actually do something, there is something. So this is like a mathematical significance. Okay, it didn't happen because of random. It was not a fluke. It was not a chance of luck. It was not like a random noise. There is a significance behind it. There is a statistical significance behind it. It happened for a reason. And that is what it's called a statistical significance test. Now the SciPy provides a module for us. Like always, it should be a SciPy dot. And this is SciPy dot stats, which gives everything about statistics. Okay. So the hypothesis is something like, it's like an assumption. Hypothesis is an assumption. So the hypothesis in statistics is an assumption about a parameter in a population. Now suppose you take India, and in India, if you want to actually find about a population, there are various different populations, right? Whether you want to talk about the northern part of India or southern part of India, they're called as North Indians or South Indians, like what is the percentage they have. Or if you want to actually take it by the caste or by the gender, that is also something. Okay, so hypothesis is an assumption about the parameter in a population. And in the hypothesis, we have a null hypothesis. It assumes that the observation, it is not statistically significant. Like a null hypothesis is zero. Null is a zero. So that we actually assume it does not have any significance. They say something, it does not have any significance. So the alternate hypothesis is it assumes that the observations are due to some reason. Okay, so this is exactly what I was talking of. Okay, it didn't happen randomly. So even the null hypothesis, excuse me, it is just like it did not have any significance. That is all. The alternate hypothesis is the alternate to null hypothesis. Okay, like suppose we take an assessment of a student. The student is worse than the average. The student is better than the average. Okay, so this is the alternate hypothesis. If you actually take this, this is the opposite of it. All right. So there is a one-tailed test. When a hypothesis is testing for one side of the value, it is called a one-tailed test. Now suppose I have this kind of a thing and I only want, suppose this is a two-tailed, okay, and I only want for this area. This is called a one-tailed test. For null hypothesis, which does not have any statistical significance, the mean is equal to k, we can have alternate hypothesis. Okay, an alternate hypothesis is opposite, which means the mean is lesser than k, or the mean is greater than k, because here the mean is equal to k. All right, this is a one-sided, one-tailed test. Two-tailed test, you can test this and you can test this also, testing for both the sides of the value. In the null hypothesis, again it equals to k. So here it means like it is not equal to k, which is the exact thing opposite. So which means it's less than or greater than k, or both the sides have to be checked. So both the sides have to be checked. So that is why we have to check both the sides in order to come to an answer. That is what they say. So this is a two-tailed test. A one-tailed test is basically, if this is equal to k, we say like, okay, the mean it's either lesser than k or greater than k. But in this area, the two-tailed, we say like, now you have to test both the things. All right. So this is a two-tailed. Alpha. The alpha value is a level of significance. Like, we say alpha male or alpha female, who have a prime importance. I mean, the prime, they are big. They're the first one. So the alpha value is a level of the significance. The more the value, the more this is. How close to extremes the data must be or for null hypothesis to be rejected is usually taken as 0.01, 0.05 or 0.1. So this is the alpha value. Okay, example. So there is a p-value. The p-value tells us how close to extremely the data actually is. Okay, so basically we say, oh, this guy was very close to getting 100. So 99 is close to 100. 99.5 is very close to 100. So something in that way, manner. So the p-value and the alpha value are compared to establish the statistical significance. So the p-value and the alpha value is done for the statistical significance. So if the p-value is lesser than equal to alpha, we reject the null hypothesis and say that the data is statistically significant. Okay, it should be lesser than equal to alpha. Otherwise, we accept the null hypothesis, which is basically it has no significance. All right, so we saw about the null hypothesis, one-tailed, two-tailed, p-value, and alpha value. I think we can actually stop here. So next week, tomorrow, we'll be starting about the codes. We'll be seeing once again everything. I trust you would have actually seen my lecture, understood it properly, and probably enjoyed it. If you have any questions, kindly contact me. I'll actually try to help and explain to the best of my abilities. Like always, I'd like to thank two persons. One is you for giving me a golden time, and the other is my wife, Jayashri, following me to follow my passion. Till we see next time. Thank you, take care, and cheers.